Okay. Hey all, welcome to Multimodal Weekly. This is a webinar series hosted by the team at 12 Labs. We've been meeting on a weekly basis for the past 5-6 months, every Friday at 1:30 p.m. Pacific time. Here's some of the topics that we tend to cover: news research in multimodal AI and foundation models, some innovative application of multimodal in different verticals, video and multimodal projects that our members could share, and occasionally we have team members on our labs talk about how to use our platform and our API. This is a list of the speakers in some of the recent webinar series. We got folks from research to startups to engineering community talk about a variety of topics related to the intersection of multimodal and foundation models. So for this talk, we have two speakers. First one is Fabian Baier, the CEO and founder of Pulze AI, who will talk about how to get locked into one single large language model and can benefit from all best-in-class models. And the second speaker is Zain Hasan, who's actually gave a talk at our webinars back in June. So he's the second time speaker, except to hear more some development with multimodal support at the database company Weaviate. Actually met both Pulze and Weaviate at one of the hackathon that we host roughly a month ago. Zain's teammate Adam was there, and I think he also connected with the team at Pulze. So excited to see some of the more partnership between these different companies come together. And yeah, this is the quick logistic note on the webinars. Folks will send the question in Zoom chat, and we have a short Q&A after a speaker finish. And so with that, I'll let Fabian get started first with your presentation, and then yeah, we can pull up with Zain in the second half.
Awesome. I'll just share my screen and see if that works. So let's see. Do you see my screen right now?
Yeah.
Perfect. All right. So yeah, I'll talk today about getting unstuck and model lock-in. So a little bit about myself. I built data centers in a previous life. Actually, I started my first company at the age of 13. There was a game server hosting company. We very rapidly outgrew basically our co-locations, and so I started building data centers. And really funny because like a lot of our customers were actually using GPUs for their sort of games, and now it's just all used for AI. But that was back already sort of like my passion for distributed systems, which I then continued while I had a short tenure over at Apple, and then I joined Mesosphere and was working there on many projects. One of them that I'm most proud of is actually Kudo, which is a Kubernetes Universal Declarative Operator, which became a CNCF sandbox project, in which we made it low code, easy, folks writing Kafka, Zookeeper, Flink operators in your Kubernetes clusters to build your applications. But how this also ties into basically this talk is we were basically building, helping folks to build applications in the clouds, so you're not getting stuck with a specific cloud vendor. And I see the same pattern actually happening now again, where maybe you build an application tailored on top of Google, and now you sort of like the more you build on top of this, have a problem switching to another provider like AWS or so. So that's sort of that vendor lock-in with higher switching costs got abstracted away by Kubernetes, where you build basically your application on top of Kubernetes, and every big cloud provider had sort of like the Kubernetes as a service. And so for you as the application owner, you just had to know the APIs of Kubernetes, but not so much of the underlying cloud. And then I also had a tenure in biotech, where I actually built the sort of like ML platform for Freenome, which was a blood cancer test. So very diverse background, but always gravitated towards building a platform, helping folks with infrastructure and making that accessible, sort of the DevOps, MOps space, or later how we see in the talk, LLM Ops. So what I want to cover today is just a quick market overview on how I see basically the market going, particular for models. Then talk, of course, about some traps and pitfalls that we have when you build an application with a large language model. I'll talk particular about our routing and benchmarking capability, which is sort of like coming to the rescue here. If there's time, I'll give a quick demo, and then I talk quickly about our observability part, and have a little bit of time, hopefully, at the end for questions. All right, so the premise basically of all of this is that's how we also started Pulze, and I really loved actually this cool sort of Star Wars picture that you showed in the beginning. Because I was asking myself, like, what sort of future do I want it to have when there's like a lot of AI coming into your day to day? Is it more like a future that looks like Westworld or so, or like Terminator, where there's this one giant Skynet, or there are multiple smaller AIs like R2D2 that is like an assistant and helping you along the way, and that is really more like a positive and pleasant future that I can see myself in. And under that premise, we came up with the hypothesis that there will be millions of these models in the near future. And how can you navigate through that jungle? How do you know which model is the best for you? Similar how Google tried to figure out when homepages came along, which is the best homepage to search. Same thing here, which is the best model for your prompt. And so I think we see already like a Cambrian explosion. Every other week, there's a new model coming out. This week, very famously, GPT-4 Turbo, and also like sort of like this FOMO that it creates, but also under the view of like model login. So the issue that you have, like, when can I actually switch? How can I be flexible? Is my model that I chose maybe outdated at some point? And typically that used to be like a couple of weeks or months. Now it's in a couple of days sometimes. And so there needs to be a solution for this, but first and foremost, people need to understand that this is really an issue when you build a large language model application, that once you sort of like this, it's like dating. Once you decide to go with one, well, you need to be careful about like who you choose. Yeah. And so the same thing happens here. Like once you decide to go, for instance, with GDP 3.5 Turbo or so, it makes it really hard to switch down the line. So you want to evaluate, you want to be very good when you're in that pairing process, in that evolutionary tree. All right. So the trap here with that model login is not new. We know login, I mentioned that earlier with, for instance, also when the cloud providers came up, but there's, for instance, also this famous blog post about that we wrote at D2IQ Mesosphere about when Snap filed their S1, and they were so reliant on BigQuery and Google's offerings that some analysts thought that this is really a login for you. And I'm pretty sure that this sort of next wave of companies that come up sort of like will have the same issue. They will have probably a high exposure to OpenAI, high exposure to Anthropic, and how can you reduce this risk? How can you build also more resilient applications that I think this week there was an outage as well with OpenAI, that you won't run into these issues and have that sort of like lock-in and dependencies. The other part is, of course, costs. Let's say you build a very cool application with a prompt that is tailored to for GPT-4, and then comes GPT-4 or Review out, which is 2-3 times cheaper. But we saw that through distillation and so forth. Actually, the quality of this is of the new GPT-4 is actually not as good. And so if you do that switch, you suffer in quality. Suddenly your prompts have a sort of like, since all of this is probabilistic, have a different sort of outcome, and the answers are not sort of in your range that you can tolerate. So there's a lot of uncertainty with that. And part of this is also, of course, just like looking on your wallet and how expensive it suddenly is, that you get locked in with the expensive model, and you don't want to do that. Quality, again, talked a little bit about this, is this black box where quality can change over time if you don't know what data was been used for the training. I think a big trend is going towards these open source models. I'm a big fan of open source, and also we see this sort of like this chaos agent meta that throws in some Llama 2 that sort of like can be fine-tuned to take on like in a very, I would say, like cost efficient way, like more of the domain specific tasks that you would otherwise use a GPT-4. So that's also like a trend that we see emerging in the market, that there will be, again, to that initial hypothesis, a lot of these models fine-tuned for specific domain knowledge and are very good in specific areas, but you need to know when to address which one of these. And the ongoing maintenance and upkeep costs, I mentioned that as already, they can become like a bottleneck as well for you, as you sort of like have to maintain legacy models because you got stuck with them and locked in. All right, so I think the solution for this is some sort of dynamic routing that happens where based on, of course, your application, folks can always know and access and tap into the newest sort of model for their specific use case. And that could be a solution that is between open source and closed source. And at the moment at Pulze, we're having over 32 vetted models that we chose from these leaderboards that we basically scored and benchmarked to fit into our knowledge graph, such as that we can enable folks to do dynamic routing. And so I showed that real quick in a little demo here. So I wrote a little basic application, a large language model application. All it does, it just asks a math problem. What is 1 + 1? And you typically start probably with OpenAI GPT-4. So I just make that request. But the interesting part there is I do it through our platform. And so the switching cost here with our platform is pretty under the hood, pretty low. You just create a new application on our platform that gives you a new API key. And then you have just the base URL that you switch. And what it should allow you is that you, when you do that request, let's do it. You get basically the answer from the model that you know already, which is at the moment here GPT-4 with a cost of 0.009 in that sort of seconds. But let's say you want to, and the answer is 2, which is really great. Let's just switch this to Pulze, our sort of meta model that gives you this dynamic routing capability, and do that same request again. And see with what model that request actually was selected. And we see AI21 Labs, J2Mid was been used way faster and also way cheaper. And so it gives you also the same sort of answer with a little bit more, of course, but that's also depends on your temperature, your max tokens, and so forth. And now we could do the same thing, and we could say let's have not just the quality as the #1 priority from 0 to 1. Let's give another way to actually cost, where we just want to have it the cheapest one. And we can do the same request as well, and then we'll choose a model request that is cheaper, but gives you also the answer, which is in this case here, Mosaic's ML Platforms MPT 7 billion model. You get the hang of this. The idea is really that we figure out what is the best model based with your preferences on your use case. And so how are we doing this? We basically started in our endeavor by using open source data sets to solve the chicken egg problem. And we used a lot of the answer-based prompts that are in Helm or in Eleuther's Harness, sort of data sets to come up with our knowledge graph. That is basically just a representation of which model works very well with what prompt. And we have that in our semantic space organized, and it organizes sort of in this little cloud here. And it grows with you dynamic. It grows with your application, depending on what sort of requests come in. You can give feedback and steer it in specific directions. But we build a global one, which is very expensive to compute. But once it's computed, it's a very cheap lookup on it, where when a new request comes in, embed basically your prompt, and then look it up in our sort of wetted knowledge graph, which one is the most similar one and what model was been chosen for that one in particular. And that way we can differentiate between the intent. We know what intent you have. Do you want to solve a math problem? Do you want to create a picture and so forth? And so the architecture of this looks like this, that I alluded a little bit earlier to. The user comes up with a prompt, we embed this prompt on our own sort of embedding model. And there we also do not have a login, because we can basically build multiple of these embedding models depending on what sort of use case you have. We see that with GPT-4 at the moment. GPT-4 has a bunch of models under the hood as well, and some sort of meta model that decides which one should you address. At the moment, we built our first one with an intention-tuned embedding model that is contrastively trained. That means to get the intent, we have very good answers and very poor answers, and the opposites of what was the intent in these. And so that's basically creating for us a very good vector space that we then use to find in our golden knowledge graph basically similar prompts just for that intent. But we can make this also for specific tasks. We can make this for specific labels. The customers can come come and build their own personalized knowledge graph and so forth. And then at the very end, as you saw, we have weights at the moment by 3 dimension, cost, latency, and quality, where the user can steer a little bit the direction where we route this. And then give the basically like customer the decide, give them the recommendation. We should choose this sort of model for that specific request, and you can do that request through us as well. And so our first version was basically going to GPT-4, I asked GPT-4, give me 20 most popular categories and give me for each 5 example prompts. So there are some papers on this where we synthetically create this. And it came up with sort of like basically then a bunch of prompts and 20 categories, arts and crafts and so forth. And that's our current latest knowledge graph that we built in July, Pulze V0. The newer one that I just showed you is 0.5. But I want to showcase that even with that sort of very simplistic approach, we saw that some models and providers perform very poorly in some categories versus others very good. So the greener, the better, the red, the worse. Not to finger point there, but Goose AI wasn't really doing a good job. Anthropic had a mixed performance, but we also saw that over time, Anthropic became better actually. And then also we saw some mixed performance with open source models to replicate, but that was just a scaling infrastructure issue because the service wasn't reliable. And then as we just like started out basically pre-computing this knowledge graph over and over again with by now over 2 million tokens, we saw that Anthropic Claude Instant V1 became very good, for instance, when it was instruction tuned, basically like, hey, for RAG pipelines, extract me these keywords and give me them back. Way better than some other models. And so the benchmarking that we use for this is two-sided. There's one is answer-based and the other one is scoring-based. I talked a little bit about the answer-based one. Let's talk a little bit about the scoring-based ones, where we have 2 answers and they're open-ended and we don't know which one is the best. And you can sort of think about it like a swipe left or swipe right, where we have both of them pairwise ELO ranked, like we see in games and in tournaments and e-tournaments as well. And we have our rating models currently, that is GPT-4, but we're also using Mosaic ML's platform for the rating, and we don't have a lock-in there as well, and we experiment which ones are the better ones at the moment for these sort of rating tests. GPT-4 is number 1, not even the new one. The GPT-4 is currently the best one to decide actually which of these 2 similar answers is the best one. And then we can also score them aspect based. How much bias is in there? How much sort of like conciseness is in there? And so forth. And all of these are relatively scored and labels that are stored in our vector database that help for your personalized knowledge graph with your preference to be retrieved as well. And that basically helps you to save a lot of costs. If you're stuck with one model, but if you actually have an opportunity cost and get other models going, you basically like have up to 70%, sometimes even 90% like cost savings. Think about if you come up with your own specific model, fine-tuned in the Llama 2 for Python code, for instance, that is specific to your code base, how these perform way better than GPT-4. In particular, these things happen when you have this, and that's where it's so exciting working with vector databases, when you have your own proprietary data that wasn't used to train basically like a GPT-4 or one of the big foundational models. And then lastly, the other part that is super important is basically observability. How am I doing? So we have a cool partnership going on with Grafana right now. We're the only large language model dashboard in Grafana Cloud right now. We have a very tight integration, so you can ship all of your logs and metrics to Grafana. And what that enables you is this dashboard that gives you a nice high-level overview on how your app is performing, particularly also if you want with the lens on costs. So you see, for instance, how when we do these routing decisions, how are my costs split in my entire account? How much do I spend on Aleph Alpha, Anthropic, or AI120 Labs, or OpenAI? But also you can integrate custom labels. So you can say, like, how does that translate over to a specific user group that you have? How does that translate over to a specific like application that you have? So this is all under the hashtag LLM Ops, which is, I think, a new evolving field where you also do prompt engineering, where you also want to know like what are the high latencies. We store that as well. So every request is basically like helping us to figure out which one has currently an outage, which one is the one that has the fastest response time to the tokens that were requested, and so forth. All right, so you can see, learn more about this actually Scale by the Bay on the 14th this next week. And then I'm in London with Grafana at Observability Con, where we release also more features, how you can even use Prometheus metrics and create alerts when you burn too many tokens, or when a specific sort of label burned too many tokens or comes over a specific cost, and can enforce your own policies and so forth. All right, well, last call here, like you can join our community, of course, sign up on Pulze and try it out yourself. But thank you so much for this the opportunity, 12 labs that I was able to present here. And I'm also open for questions if there are any. I'm happy to answer them.
Awesome. Thanks, Fabian, for a very detailed and highly informative presentation of the platform. If the audience have any question, feel free to unmute or put them in the chat. I think like
I have one question. Maybe I can go ahead.
Yeah, please.
Can you guys hear me all right? Yeah. So super interesting, and this is highly relevant. So you're probably aware of the OpenAI issue. It went down after Dev Day. Like this would be a perfect solution for that, right? Because you could just switch to another large language model provider, and then when it goes back up, you can kind of do this load balancing act between large language models. So this is very cool, very good presentation. My question was more around the vector databases part. So I'm going to be talking about vector databases, but which vector databases have you integrated with? And then also, you're doing evaluation of large language models, and then this analysis of which one is more cost efficient or not. Are you also doing that with the vector database providers, or is that more of just a like you choose one and then you're mainly focusing with the analytics around LLMs?
Yes, we do that also with the vector database providers. And currently, we do not want to have a lock-in with the vector database provider as well. So we're using Milvus and Weaviate at the moment. Some of them like scale very well. The overall overhead, the number one criteria for us is really that these sort of lookups and also like the sort of data that has been basically crunched and stored there doesn't create as much overhead. And so we currently we're doing like having a 15 milliseconds to 25 milliseconds overhead and having with Milvus and Weaviate the best results. And you can almost think about that some like depends on how you do that sharding and so forth for the customers with the personalized knowledge graph. You can also spin up the entire sort of like stack that we have like through a Helm operator in your own Kubernetes cluster, so that like you don't have noisy neighbor problems and so forth. So that's also possible depending if the data grows. And the other interesting part is like if you build your own RAG pipeline, sometimes it really depends. Like if you use Pinecone, there's no open source offering for this, and maybe they are like also like hammered on and their API doesn't respond very fast. That could impact us as well. And the same sort of routing idea with redundancy goes into this as well. So you have sort of like fallback options. I didn't talk about this, but if one of the models that was chosen is not responding, we do an exponential backoff, and you can decide there as well, do 2 times an exponential backoff or so, and then to release the pressure on that API basically. But if you don't, then just hop to the next best model and so forth. So with the use case that we saw this week when OpenAI was down, then find the next best model, so there's no impact for your customer use. But it's cool when you have a hackathon thing going on, and you know, there's maybe you're on stage, then you want to have it work, but maybe a recording can help. But once you have that in production and serve that to live customers and paying customers, it's a different ball game. Also, like with the scale, suddenly these things become relevant, like costs, which tokens you burn, even slight sort of like differences can with your prompt and so forth can make a huge difference at the end of the month. So
very cool, super awesome. Thank you.
I'm just curious on that slide that you just shared. Can you elaborate more on the intention tool embedding model?
Yes.
What does it mean to like intention tool?
Let me share that again. So like there's what one thing that is interesting is when I saw that like intention is for me sort of like a bug. I think the the models, they become better, and then they figure out what your intention was, so you don't have to figure this out. So it will sort of be replaced. But we're not there yet. And if I send, for instance, like there are some multimodal models that are very good. And do you want to create now a picture? Do you want to have maybe text or so, where they get the intention? But let's say, just for the example that I had here with, the user tries to have a math question answered. So then we tie this directly in our vector semantic database on, okay, what were those similar vectors that were used in our hopefully very broad prompt space that were about math problems and ABCD choice questions and so forth. And those are the models that hopefully should be returned in the vector base as the closest model to that specific prompt. And they would help you then to basically tell us, okay, for these sort of like categories, these models perform very well. We don't have Wolfram yet on our, but one thing how we try to solve this is by like going into open source and fine tuning our own models and allowing them on our platform. But you could also potentially bring your own fine tuned model, and we just score it and add it into your unique personalized knowledge graph to identify then the intent specifically from your users, to then just choose these models when it's relevant. And the intention tuned really is what I mentioned earlier, that contrastive trained sort of model that creates just an embedding that is very good within our vector database to get the right intent out of the initial prompt, such as that we can make the proper routing decision. And there's a lot of like open source data sets that we chose here, Big Bench, Evaluations, Harness, and Helm, that help us already to figure out to specific prompts what the intent was to basically like the model, by the way, is an SBIRD model that we used for our embeddings that runs on TorchServe. We have a blog post about our initial categorizer, and this is just a continuous sort of like application of the same pattern. And with that, we are able to swap these models and train them with new data that comes in to be better and better in figuring out what the user actually wants. But that is just one component. The intent is just one component. If the user needs, for instance, a JSON structured output, or wants to have a specific sort of like extract always social security numbers and emails out of this, we want to detect this as well to then route it to a model that is very good when it comes to that. And we're almost thinking of like sort of like workflows where you have pre-processing and post-processing, where you can stack multiple of these models together.
Yeah, so it sounds like based on the prompt input, this model will by similar prompt embeddings in your knowledge graph or vector space, and then recommend the appropriate LLMs, right? That could, be the best. That would be optimal for the users using that prompt, right? And
exactly.
Yeah.
And optimum is different per user, per application. There's not one size fits all, particularly when you want to do this with your own data. And even if you have like a GPT-4, it's not trained on your data, so it's really hard to give you the right answer. Maybe through few shots and so forth, you can do that. We saw also like Croc 1 coming up, and so there's all these models that are constantly coming, but you need to evaluate them first. And that's sort of the idea, that we built this very good tool that evaluates them, but also the evaluation is just like half of the solution. What you really want to do is like you want to put this into action, and that's where I think the magic really happens once this is connected with the routing component. But that keeps it also very agnostic. So it can be used, for instance, because it's backwards compatible with OpenAI, can be very easily integrated with every provider that integrates with OpenAI, which is at this point, I think almost everyone. Llama Index, LangChain, everyone has like an OpenAI provider.
And it looks like from the presentation, the three-dimension model evaluation is on like quality, cost, and speed, right? Based on the demo that it shows, and you just like choose
Exactly.
basically turn on the knob for what dimension you want to prioritize in order to get the appropriate models return.
And there are, of course, different qualities in how good your embedding is, and so forth, and that can become better over time, and iterating on this. But it really starts with like having the right data to do this, and also using open source data. I think for transparency, that we don't introduce bias is a big thing, and that you want to be careful that you don't introduce bias there, but you also want to make sure that you can basically like connect that with your own proprietary data, such as that you, if there's not the right model that is maybe with, there's a new question coming in that no one has seen before, that you dynamically start evolving that space. And so the application learns with you over time to make the appropriate routing decisions. And we see here already some of the questions here, there are also math questions and how it organizes itself in its own sort of space. And we then cluster that and take a few of these prompts to then replay them and with all of the models on our platform, and then rate the answers. And that is basically then our sort of like score that we come up with. Also, one other thing lastly is I think the scores can be very overwhelming and complex. And so they're like the 7, 8 scores. Suddenly, if you look at how Croc 1 was evaluated, they had already like this high middle school sort of math test or like a school test and so forth. And then, but how can you like compare apples with bananas? And so like that's another thing for the user that just wants to like integrate this. How can you make it very simple? And that's why we currently decide on one score. In the response, you see that we like give you this sort of like best models as one score back. But what we are thinking of is also like adding in this sort of scores field more of the scores, like maybe after a specific intent, after a specific sort of like task and label, and that can help you as well to then for us to do routing decisions, but also helps us to basically learn more about making the right decision for you. So
yeah, awesome. Yeah, thanks Fabian, thanks for a great presentation. I'm excited to follow up with the roadmap of the post and see more benchmarking, but report that you do for different tools of the MLOps ecosystem. Perfect. Zain, you want to start my talk? I know you have some demos you've been working on over the week, and yeah, excited to see how the Weaviate perspective of multimodal and incorporating that some of the latest updates from OpenAI.
Yeah, awesome. So last time I was presenting here was, I think, in July, right? So it's been a couple of months now, more than a couple of months, but I wanted to show what we've been working on since then. And this is pretty exciting. So when James asked if I wanted to present here, I kind of leapt at the opportunity because OpenAI announced that their GPT-4 vision model is now accessible through API. And the last time I was here, I talked about, I presented this paper that was released at a conference earlier that was talking about multimodal RAG. So everybody's talking about retrieving text documents and then sending them off to a language model that can read them and then generate with. And so what we were building at that time was the ability for users to use Weaviate with multimedia, more than just text, but also images, video, audio. And this in this short demo talk, I'm going to talk about how we've kind of structured Weaviate such that we can plug and play different embedding models, and people can build their own modules. If there's a new multimodal embedding model that comes out, let's say, and you want your data to be vectorized using it, you can create a module for Weaviate using that. So I'll talk about that, and then I'll talk about how that enabled us to create this scalable multimedia search engine that you could build with Weaviate in under an hour by enabling this module. And then just a couple of days ago, now that I can retrieve images from the vector database, I can now also call an API and send that image along with my prompt to OpenAI's new vision model, the GPT-4 vision model. And now you can get the vision model to talk about the image that you just retrieved. So this idea of having a multimodal retrieval augmented generation. So I put together a quick notebook to show people how you could build multimedia search with Weaviate, and then how you can just add a couple more lines of code to augment that with retrieval augmented generation. And then you can get the large language model to talk about images And then I put a little bit of a twist at the end there as well. So I think that'll be interesting for folks that are watching this. Okay, so I want to start talking about how the Weaviate module system works. This is a big part as to why Weaviate, we call Weaviate the AI native database. It's because the AI models, the embedding models, are integrated directly into the database. Right? So if you think about how this entire how this 1 second, let me move the camera out of the way here. If you think about so if you think about how the vector search pipeline works, essentially you have some sort of encoder or machine learning model, also known as an embedding model, and you pass in your data to this, and that gets encoded and it gets stored in a vector database. And then when the user comes along with a query, that query goes through the exact same pathway and it gets encoded. Now, there's some embedding models where you have a different query embedding, but for this case, let's say that you only have one embedding model and the query gets embedded into the same vector space. And this allows you to do some sort of proximity search, which then retrieves a list of relevant results for you to show back to your user. Right? So what we've done with Weaviate is that we've actually enabled it so that when you want to specify vectors, you can do this in multiple ways. One approach is to bring your own vectors, and a lot of other vector databases actually follow this approach, and they're limited to this approach. And that's what this looks like, right? When you want to specify what your data looks like to your vector database, you specify the human understandable object, so you can think of it as the text, the image, or the audio, along with the vector representation of the text. And what this necessarily means is that you have to handle the vectorization of your data client side. So I have to go take my data, pass it through a model, perform inference, take the vector, and then kind of append it to the object that it corresponds with, and then pass it into to the vector database. Right? So you can do this with Weaviate. But what we found users really like about Weaviate is that you can do this second portion as well. You can pass in only the data object, and then you can get Weaviate to generate the vectors at import time for you. And this is quite good because you can get started with using a vector database really quickly without even knowing what an embedding model is, right? And then once you know what an embedding model is, if you have a fine-tuned embedding model, then you can kind of scale up to using your own, creating your own module. But the second piece makes it so that you can build really quickly production level applications with Weaviate. And what this architecture looks like is like so, right? So you've got the top portion here that I showed earlier, where you pass in your data, but now you only have the data object. You don't have the vector. What you do when you pass in the data object, or even before you pass it in, when you're creating the schema, is you specify which type of vectorizer module you want, right? Whether it's text you're passing in, whether it's a multimedia that you're passing in, whether it's images that you're passing in, you specify the vectorizer module. And that allows us to, on the back end, set up this sort of inference pipeline where, let's say you tell us that you're using OpenAI's text-to-vec model. Then we can call and you let us know what your OpenAI API key is. We can call an API, and we can get the vector for the data point that you just passed in real time, right? So this workflow happens in real time, and this way you can pass in data objects, and then we vectorize them as we're indexing the data objects, right? The other functionality that we've also added here is that you can take open source models and you can integrate them as Weaviate modules, so that even if it's not a closed source model, let's say you have some sort of model like Clip or ImageBind or a derivative thereof, you can run that locally, and you can specify to Weaviate that anytime I pass you a data point, use this module that I've created myself, and then that is going to be run locally. So in this demo that I'm going to show you, I've got the ImageBind model running locally on my computer. That's why it's kind of slow. But if you wanted, you could have this piece of the puzzle running on a beefy GPU computer. And then you can have this piece of the puzzle, the Weaviate core, running on a computer that has a lot of RAM. So you can optimize the compute accordingly. So in this case, what the demo that I'm going to show you, I'm going to pass in data points to Weaviate, and I've already specified, and I've got a Docker container running that's told Weaviate that I'm going to pass in multimedia data. So I'll pass it images, video, audio, and it's going to go in and create the vectors for these data points using the ImageBind model that I have running locally on my system as well. Okay, so the one main application I wanted to talk about here that I also teased in the last presentation in this webinar was this idea of multimodal RAG. And at that point, I could only show off basic RAG because for two reasons. Firstly, we didn't have a multimodal embedding model integrated into Weaviate directly at that point. And then secondly, we didn't have a large language model that could understand multimedia, right? We had in academia some small models that could do it, but now with GPT-4V, we actually have a large multimodal model. So now I can actually show a demo of this in action. I think this was also already covered in Fabian's talk, but I've got a couple of slides here that just explain really quickly what RAG is. So this is how we all use ChatGPT typically. We ask it a question and then we get some sort of response. RAG is a very simple augmentation to this, right? All you have to do is now you ask your question, but you also give it relevant documents. And so you could ask it, for example, who at the Christmas party is allergic to peanuts? And ChatGPT wouldn't know that, but if you specify a list of, let's say an Excel sheet or a list of people and what they're allergic to, then it can actually read over and reason over that to give you a customized response. Right? And that's as simple as what RAG is. And why a vector database becomes important here, whoopsie, go back full screen here. Why a vector database comes in handy here is in order to find out relevant source material, it's quite important to do this really quickly. And if you have your knowledge base is hundreds of millions or billions of documents, you need to be able to search over this really quickly. And so retrieving this source material quickly is what a vector database specializes in. And secondly, the reason why you would go with a vector database, you could go with really any database. You could go with a SQL database or something like that. But the reason why vector databases are the first to go to is because you can query them using natural language. And large language models are natural language generators. They excel at that. So it's easy for them to create the query as well. So now you get the vector database to retrieve for you, and you can get it to, and you can get the large language model to generate a customized response. The cool thing, the twist here, last time that I presented, was this idea that you could now do multimodal retrieval along with generation. So this idea of multimodal RAG, where you could use this prompt to retrieve from a multimodal memory. So if you have, what I'll show you in a second is multimodal memory, where in Weaviate, I've stored video, audio, and images. And then you get back text and images. And if your large language model, the generator, now understands both of these modalities, you can get it to generate things that read or pay attention to information both in the text and the image. Right? In order to enable this, the reason why I couldn't demo this last time was because we didn't have large language models that could take in multiple media as input and generate multiple media as output. We do have that now, so now I can demonstrate what this looks like in action in Weaviate. And so that's what I'll do right here. So let me zoom into this a little bit so that everybody can see clearly. So what I've done here, I've actually got this whole thing running locally on my system. So just to prove to you, let me bring up my dashboard. So this is Docker running in the background. I've got, so if you remember that architecture that I showed earlier, I've got the Weaviate container running here. This is where the vector database is running out of. And then I've got my inference container that is running the ImageBind model over here, right? And this is a pretty beefy model, so it's taking up a lot of memory here. But all of the inference that you see, all the vectorization that you see that I'm going to do is all happening locally, as well as for the query. Okay, so the first thing that I do is go ahead and connect to my local Weaviate client that's running. And then I've got a data set where I'm going to specify a schema where I've got images, audio, and video. Okay. For this one, I don't have text fields. I'm using the text fields to specify where those data points are, where those media is stored in my computer. Right? So it's just a file path for this purpose. I'm not going to vectorize the text fields for this purpose. One more important point here. So when you define the schema in Weaviate, How you access the module system is by specifying the vectorizer. Right? So here, we've actually created a multi-to-vec bind module where if you enable this, then it'll let us know that your intention is to use or run a locally ran version of bind, and then you can actually use that to create these multimodal embeddings. So this is where I specify my vectorizer, and here, because the ImageBind model is actually 5 different models running together, and they've been unified using a contrastive loss, you have to specify which type of query or which type of data point you're passing in so that we can internally route it to the right model for ImageBind to vectorize using, right? And the way you do that is by specifying whether you want to pass in an image field, an audio field, or a video field. You could also pass in a text field and you can vectorize it, but in this case, I'm not doing that. But there is a text model as well that is built into ImageBind. So you specify this in your schema. You create your class, and then you're ready to just start importing data. And notice how I haven't vectorized any of my data. All of that will be done at import time because I've already specified the fact that I'm going to use this vectorizer. So for this purpose, all the media that you pass in has to be base64 encoded, which is also what OpenAI requires, as we'll see later on. But I'm going to go through, loop through all of my images. Just got, for demo purposes, 9 images for now. I'm going to loop through them. I'm going to pass in the path for that image, as well as the base64 encoded version of that image. And then I'm just going to add those data properties. So each one of those gets, the embedding gets generated, and the image gets converted to base64. It gets added to Weaviate. So all of these are added. And then I do the same thing for audio. So here, the only difference now is that I'm importing it as an audio property. So it knows that in order to vectorize this, it has to use a different model behind the ImageBind module. Right? That's the only difference. Everything else is pretty much the same. Of course, the files are audio files here as well. Right? Same thing for video. So ImageBind actually uses the same model for, I believe, image and video. They just use, they generate frames per second, 2 frames per second, and then they vectorize it using their image model. But in order to tell Weaviate that this is a video and to treat it accordingly, I pass it in as the video property. So this is all pretty stock standard. I've imported in all this data. And the reason why I've already done this beforehand is because it takes time to vectorize these, especially on my local computer here. Especially if you have big videos, it takes some time to vectorize these. Then I just go ahead and check the fact that this stuff is in my database. And then and then I can start querying, right? So at this point, you pretty much have a multimedia search engine. So you can do this text to media search, where if you want to search with text, you can pass in this query and you can say, I want to search for this concept of dog with stick, and I want to get back the path for the image or the media that comes back. Right? And when you do this search, you get back a video, you get back a couple of images. Okay? And what I'm going to do here is I'm going to pull out this image, this dog2 image, and this is what I'm showing here. So now that I've retrieved this from the database, what I'm going to do is pass this in to a large language model to reason over. Okay? And this is new functionality that I couldn't have shown earlier. So what I did is I tried to put this together really quickly. What you can do with the new chat GPT, GPT-4 vision model is you can actually base encode this image as is done here, and then you can pass it in to OpenAI's completions API endpoint. And all you need to do is specify that you want to use the GPT-4 vision model, which we have access to. I don't think it's openly accessible right now, but you pass this in. You pass in the image, so that image of the dog, and then you can pass in your prompt, right? So here the prompt is very simple. I just wanted to describe what's happening in the image. Then I limit it to 300 tokens. And then I get back this response. I've just parsed it here. And it's actually fairly accurate. It picks up on all the details. It picks up on all the writing. And this is the essential stack of multimodal retrieval augmented generation, because I retrieve the image using text, and then I've passed that into a large language model to reason over and got it to generate this caption for that image. Right? One other thing that I mentioned during my presentation was that if you had a large language model that could generate images, you could also ask it not just to describe the image, but you could say, redraw this image or give me another version of this image. Unfortunately, right now, GPT-4v doesn't output images. There are some open source models that can do that. They're not as powerful, they're not as good, but I wanted to show that functionality off. And in the future, I think we'll have this functionality built into the large multimodal model. So what I did here is I took this description and then I sent it off to DALL-E 3 so that it could generate what image it thought this was a description of. Right? So here I call a different endpoint, DALL-E 3, and in the future, who knows, this might be part of one model. So the large multimodal model might understand both the text and then be able to generate images as well. But right now it's two separate models. So here I pass it the description as the prompt and I get it to generate a image for me. And what came back was pretty surprising, actually. The image that it generated actually looked better than the original image. And if you look at this, I'll send this notebook out later, James, so you can share it with people, but it gets all the details pretty accurately. And I think the next step is to have a large multimodal model that can also generate this, right? Even if it's separate models on the back end, you could kind of mix it together. Also, it added a bunch of details here, right? So these hearts, I don't think that was part of the description here either. We don't have this, but it kind of created this portion here as well. So this is pretty exciting. I'm also working on more content around this. So there'll be more interesting applications of this. I'm going to release a blog around this. So if you're interested, I would recommend reaching out and reading what we're talking about. And the last thing that I want to show is now that we have this full-fledged multimedia search engine, you can now go in and do media search, right? So this whole stack that I showed right now, I queried with a text, I got back an image, and then I got the large language model to generate a description of that image, and then I got another model to generate an image off of that description. But just based off of the base Weaviate functionality, you can go in and do all sorts of multimedia searches as well. So let's say you wanted to search with this image as an input, you could go in and do this near image search, right? So here, if I'm doing this near image search, I can pass it a path for the image. And because ImageBind on the background understands how to vectorize images, it'll route it through the exactly correct model. And then it'll give me the 5 most relevant media as responses. The first 3 media here are all images, but notice how the 4th most relevant media is actually the sound of a cat meowing, and this is also a video of a cat. So this is a full-fledged multimedia search where you can pass in any type of modality and then search respond. It'll respond with any other type of relevant modality as well. My favorite thing here is the audio search, actually. When you pass in an audio file as a query, I don't know if you guys will be able to hear this if I play it, but let's try it. You guys hear that? No? Okay.
No.
Believe me, you'll have to believe me. It's the sound of a dog barking. So with this one, what we did is we made it so that users could easily specify what type of query that we're passing in. So this is a near audio search. I want to know what's near this audio file that I'm passing in. And here I get back because it was a sound of a dog barking, I get back a video of a dog playing with a stick here. So this is the video that matches most semantically with the audio that I passed in. And then you get back a bunch of other videos and audio files here as well. And then there's nothing stopping you from passing in an entire video as your search query as well, right? So this is the search query here where I passed in this video of a meerkat, and now we're doing this near video search, and we get back videos and images of meerkats here as well, and then I'm just playing them locally. So we get this back as the closest match. was interesting is that it actually matched what the meerkat was doing. I didn't notice that beforehand, but if you look at what the meerkat is doing, it's actually, the frames are quite similar. The activities are quite similar. And so here, if I go in and if I look at the second one, I want to see what that second matched video is doing. Oh, this is going to take a while, by the way, so shouldn't have ran that. I was just curious, but this vectorizes the whole thing on my local laptop. So I can go back to my slides and then I'll come back to this and this will be done. Okay. So that whole demo, you can actually build within an hour, a couple of hours with Weaviate because of this module system that I talked about earlier, right? And now that we have this capability, I can actually use this meme. I've been saving this. So hopefully now people are getting really excited about large multimodal models. I've been on Twitter and people are, all they're talking about is multimodal RAG. So that's really exciting. It's really cool to see what applications people think of. That there was an application that was published where people are connecting this GPT-4V to their webcam, and then they're getting it to do real-time captioning identification. So it'll be really cool to see what industrial applications this enables, right? But yeah, that's everything that I had. Check us out. If you want to ask questions, feel free to reach out to me, or if you have questions now, we can take those up as well. And while we're going over the questions, I can actually see if this is, yeah, so this one completed. So this is the second video that matched with my meerkat. And notice how here they're doing something different, right? So they're not actually looking left or right. So it's pretty good, actually, this embedding model, ImageBind from Meta. It actually matches the activity of the animal as well. So it's pretty cool.
Yeah, it's definitely super exciting to like see this demo in real time.
Yeah.
So just correct. So you use ImageBind as the original, the first part of multimodal RAG. All right.
Yes.
Great.
Exactly.
Get all the multimodal embeddings based on the audio, image, and video input, and then use store these embeddings in with it, and then use GPT-4V to describe things happening in the image. Use DALL-E 3 to generate net new images from the text. Right.
Exactly.
Yeah.
So here I retrieved this image using this concept, so dog with stick, and this is the closest thing that it matches. So I got this image, and then I passed this image in here. So this is the source doc2 JPEG. I passed this into GPT-4V, and I asked it to tell me what it was, what it described, and I got this description back.
Yep.
And then because GPT-4V can't generate right now, I got DALL-E 3 to generate what it thought this description was of, and you got this back.
Yeah, perfect. Yeah, this is, yeah, and also like some of the like any to any search, right? That you showed at the end was very impressive as well. Like audio as a input, video as an input.
Yeah.
And then that is all thanks to the quality of the ImageBind embeddings, right?
Yes. So this is also, so I was planning on doing talking a little bit about this idea of interpretability and explainability behind these multimodal models, but I thought that would be too much. But I can, now that we've kind of veered onto that topic, what's super interesting to see is if you look at the quality of ImageBind, there are some modalities that are more superior. The embeddings are more superior than other embeddings. So for example, of course, the image embeddings are the best, which is why they used it to connect all the other embeddings. But their audio embeddings are also very high quality. Their text and their other embeddings are not the best, right? They're still very good, but they're not state of the art. They actually broke some state of the art with their audio embeddings when the paper came out. So it's very good for audio. What would be really cool to see is if I do a multimedia search. So let's say I go in and I search with this image of a cat. What would be cool to see is which modality it matches and what the which modality is most responsible for matching here, right? So for example, I pass in an image and I get back an image, but that's not always the case. So some examples I showed you here, you pass in audio and it actually matches more with a video rather than an audio. The audio is the third highest match. 2 videos are the first and second highest matches. So it's not just doing this kind of modality isolation and then doing what is the closest within this modality. It actually does this pure cross modality search. And what I was thinking about is it would be cool to see, given a query, how responsible is each modality for making sure that that these queries or these responses are close or not, right? Another way you can think about it is if you do this multimodal search and you ask a person what type of burger they like, and one person really likes the smell of their burger, right? Then that the smell modality for them will be higher weighted than the audio modality or the taste modality for example, right? And there's a lot of work that's actually going on in this space as well. Now that we're getting into this multimodal space, people are starting to talk about the importance of modalities and how one modality might be more important to one downstream task, whereas another modality might be a lot more important for a different downstream task. So that's really fascinating as well.
Yeah, I think like super excited to see the excitement on that front. I read a blog post on this just a while back, and I actually go into like the sort of the theoretical pinnings of multimodal ML research, and I think it did mention something along the lines of I think like figuring out like what modality is more dominant with respect to each other in a specific context. So that's actually like quantifiable studies of things that can do that. But I think the most exciting thing is like seeing like the last meme that you have with Drake. I think like throughout this past year, a lot of the work that I've been doing with Wallace, but also like with the broader AI communities to like sort of shaping the categories of multimodal AI. And I think like if we think about like say February or March, right? I think most of the conversation was still surrounding LLMs and how like so many other companies that just view LLMs, right? And now I think it looks like the dialogue around multimodal has really ushered, and companies that focus on different modalities besides text are really getting into traction, not just like the stable diffusion in the world, but also like sort of the connectedness of like embedding this model. That's I think that
and I feel like the reason for that is, if you think about it, people are really excited about large language models because of their ability to generate human-like language. And then if you think about how humans actually learn, it's not immediately through language, right? So when you have a toddler, so I have a son who's about a year old, he's only starting to speak a couple of words now, but he knows so many things. He can actually point you to exactly what he wants, and he can convey to you what he wants you to do with that object, all without language. So humans build up this foundation of multimodal learning, and then they kind of fine tune it with language. You can learn a lot of concepts with language, and it's very efficient to learn more complicated concepts and reading things. But the basis is set in multimodal learning, right? And I feel like people are now saying, okay, more than just, if you have only a large language model, you can't get it to look at things, describe things, interact with things. And in order to build towards this idea of a general intelligence, we need a model to kind of take in those modalities, understand a data point from those dimensions as well. And that's where I'm really excited that people are exploring the space now.
Sure.
People in industry, I think academia has been working on this for so long. It's a lot of exciting work. Industry and like people are actually now very excited about this. So I think that'll accelerate the pace at which we see things happening.
Yeah, for sure. I think like I think 2 points, like from think at 12 Labs internally, we think a lot about like releasing the video embeddings that we have. And we are doing a bunch of like benchmarks to like compete it with like other existing open source project. And then that video embedding space is like multimodal inherently because of the image, the audio, and the audio part of it. So I think like seeing the code that you show was really exciting to see how the kind of demo that can be built with that embedding. So I think it's set me a lot of inspiration to talk with the team and build faster and release these cool demos. And then the second point I think is also, maybe Fabian can also chime in on this, is like the evaluation part of it, right? So it looks like that is like one of the challenge with like the future, which is like if evaluation of LLMs are hard, then evaluation of large multimodal models is probably going to be even more complex.
Yeah.
So yeah, it's likely there will be like a lot of different dimensions you would have to think about to choose the best multimodal embeddings model, like for use cases.
Yeah. Like the evaluation part, I don't know if there are even like good frameworks existing yet for evaluating multimodal sort of like models. Like think about good labeled videos and images and sort of like some golden sets there, like for this. I don't think they exist yet, and I wish they would be also open source so folks can use them. There are, I don't know, last time I checked on Hugging Face, I think there are like 10,000 data sets, but I don't know how many of these are already like including some of multimodal aspects like media, like audio or video. The other part that is also interesting is, I think, to like how toddlers learn is in the first stages of their life. They're just observing, and just so you learn through observation. And you have a few shots learning. Like if you look at a 11-year-old or a 12-year-old, they watch doing someone opening this thing here once, and they can do that. And large language models, even multimodal models, I don't know if they can do that yet by just observing and then like have an agency over it and doing it. So that's also a very interesting field as we go to like more like a general intelligence. But I think we need a different architecture. I do not know if the multimodal architecture would even support that. I immediately more got sort of like reminded on this sort of Tesla driving, that we finally can detect the stop sign, but please don't run it on your own little, run it on a dojo that is fast enough so it detects it in time. Yeah. So it can take some actions of it, and text as sort of the transport layer of, I think also when Stability AI built these sort of things, how they bounced it back and forth, like to that like Free Kisses little French bulldog demo. Like now you can take that image and have it described again or stored it in your database and see then how this optimizes itself to come out then with a very good realistic picture of what you actually want, which is also very interesting to see if you have these things sort of like bounce around a little bit and do these operations. Yeah, so that's what gets me also excited. But from a standpoint of having the right data set, I think we still need to create that and in order to do the right routing decisions and knowing which one is good, which one is bad.
Yeah, what I was mentioning earlier, that this model that we're using, ImageBind, right now, it works well for some modalities, not for others. That's mainly because of the lack of some data sets to bind those modalities, right? So if you this model can understand like accelerometer and gyroscopic data, but that modality unsurprisingly doesn't work as well because they don't have that much data to bind gyroscopic data to video data, right? That's like a very special data set, and it costs a lot to create that data set. Whereas audio and video and images, like you could take a YouTube video and that has those two modalities already, and if you transcribe it, you also have the text modality. So I think data sets are the really big limitation when it comes to these modalities. And then also you have like there's all sorts of interesting modalities. We don't have data sets around those, right? So there I read a paper from Google, which has then spun out as a company now. They're creating a odor map. So they're building graph neural networks that take in molecules, and they kind of project this into a vector space of what that molecule smells like. And the data set for that, can you imagine? It's super difficult to collect, right?
Yeah,
I feel like that's the bottleneck there.
Yeah, maybe through Apple classes we get more and more of that sort of data that can, and some there. I think some companies they're trying to create this real world database that can be then used to plug in and do some RAG on it, maybe. Like it's in its infancy, and multimodal is just getting started, I think. So I'm very excited for seeing really like use cases, applications built with this, not just like the search that you would expect on YouTube, like find me a similar video. The other thing with Wave, by the way, I thought about, like, immediately I have my own Shazam. So I don't need to use Shazam anymore. I can just like build this by myself almost. Yeah. And maybe way better, because these days Shazam just doesn't really like sometimes hit the right note. So that's interesting as well. Also for music production, creativity, coming up with your own sort of like melodies and that is, I think, also very interesting.
It's very interesting that you mentioned that, because just last week I was in California. We were running this hackathon at the Open Data Science Conference. And one of the solutions was this Shazam clone, where they embedded all of these Drake songs, and then they searched with a Drake song that wasn't in there. And it actually met the melody quite well. So because the model doesn't understand like words, so they were trying to do this, they were trying to match the words, the lyrics of the song. It didn't work as well, but the melody matching was pretty good, actually. They searched with a cover song, and it actually picked out the original song as well. So it works fairly well, the audio search component of it.
Very cool, yeah.
Super cool. Perfect. Maybe one last question. I'm just kind of curious, Zain, because you run ImageBind locally on your computer, so I assume it might take some time to like vectorize the different modalities, right?
Yeah.
Like, for individual developers, I assume like if you want to do something quickly, the indexing time, like vectorization process, is definitely like one of the bottleneck, because if you work with multimodal model, obviously I'd say like the time it takes to like perform vector representations just gonna take longer compared to like what you do with text embeddings. Do you have any like just from your own experience insights in sort of the things that you encounter? Just pinpoints. The reason I'm asking is like by interning your trial labs, one of the friction point that we have, especially when we host hackathon, with what you guys last time was like it's a long indexing time with a lot of requests. So how do we like improve that experience? Good curious to hear.
Yeah, especially for like, let's say you're getting people excited about something, you're putting out a demo and you want people to be able to do multimodal search. You don't want them to sit there and encode like 500 videos and then just say this is not working and walk away. So the solution that I found for that is so there's a couple of solutions. One solution is you provide them all of this media data, but you provide them the pre-embedded vectors along, so that when they're putting data into Weaviate, you can use the first architecture that I showed you, where you have the data and the vectors, and they're doing no inference. The only inference you're doing is at query time. So if you pass in a video, now that needs to get vectorized, and that takes a little bit of time, but the setup is like almost instant, right? That's one solution. The other solution that I found, so I like the first solution better, but the second solution I think is a bit of a compromise, where what you can do is embed in all of the different types of media files, and then you can do only a text search, right? Because then you can provide this pre-embedded kind of image of Weaviate running that has all this media, and you allow them to do only text search, and the text is really quick to embed, so they get the feeling of multimedia search, but they don't get the full any-to-any search experience that I showed in this demo, right? This is why I like the first solution better. But yeah, the other thing that we're potentially a third thing that we're working on right now is async indexing, where you can pass in as many media files as you want, and then it'll ingest all of them, and then in the background it'll start indexing them. So you can start to perform queries immediately, but the limitation is that only what's been indexed will get retrieved. But then as you start to index all of it, then you can perform the full search. So I feel like for nice demos and conference talks, those could potentially be good solutions.
Yeah, thanks for sharing those for talk. Awesome. I think we like went way over time, but I think it's a really great discussion. And yeah, Zain, if you could share the notebook as well with me, so I can include that in the recording description, so folks can play around with it.
Yeah, for sure.
Yeah, thanks Fabian, thanks Zain. Appreciate your presentation, and I will share the recording on YouTube in probably like 2 weeks for folks to peruse in their own time. Enjoy the rest of your weekend.
Thanks, folks. Have a good weekend.
Thank you, everyone. Bye.